Welcome back to yet another series of Learning Simplified. This is the second of the tech series where we explore the new 23C feature of lock-free reservation. So let's understand the problem statement. Let's assume a table called ACK balances, which has got three columns: the account, which is the primary key, the name, and the balance. Let's assume that the transaction 1 tries to update the first row of 1001 with the transaction amount of plus 10, a credit of 10. Now it may take some time to commit because of some processing logic of the application. In the meantime, if this another transaction 2 comes in with a debit of 50, the transaction 2 has to wait because transaction 1 has taken a TXN row lock on the row. So transaction 2 has to wait for some time, and based on the application logic, it might do a retry, and after waiting for some time, it will time out. So transaction 2 fails. So this is a familiar problem when we have tables like balances, quantity of inventory, stock exchanges, etc. So how do we solve this problem? So this is where the new feature of 23C, the next long-term release of Oracle, comes into play. So a similar scenario, what happens is this lock-free reservation enables concurrent transaction to proceed without being blocked on updates made to reservable columns. Now, what exactly is a reservable column and how do we achieve this? So first, let's understand and define the attributes. In this table, we define the balance as the reservable column. We will see in a little while what reservable column means. The table where we want to use this feature must have a primary key. It's a must. In this case, the account number is the primary key. Thirdly, the balance column should not be an index or a partition key. The balance column here is the reservable column, and it's important that these reservable columns has to be a numeric, which means it has to be an integer, float, or a number. Finally, the update which you make to this table for balance should be based on delta amount. Now, what I mean by this? It means that when I update this table, update table is set balance equal to 110. That's now how we should do it. We should do update table is set balance equal to balance plus 10. So the delta amount should be there in my update statement. The reason why we're going to see in the next slide. So how does it really work? So what happens is that the moment we define balance as a receivable column, automatically Oracle 23C creates another table, an internal table called sys reserve journal underscore 100,666. Now this 100,666 is nothing but the object ID which you find in user underscore objects of fact balance. So this is the dynamic portion. Sys reserve journal is the reserved word. Now this table has got a number of columns. So the most important column here is the primary key of the table. The account comes as a column here, balance underscore OP, which means balance is nothing but the reservable column here. So the reservable column underscore OP means the operation, and then the same balance underscore reserved, which means what is the delta amount which you are filing in the update statement. When we look at the next example, it will become quite clear. We will take a similar example of the ag balance table with the primary key as account, name, and then the balance. The reservation journal table with the object ID is as below. First, let's assume the transaction comes of minus 100. As soon as the transaction comes and before committing, a row gets inserted in the journal table with the operation as minus and the balance reserved as 100. The second transaction of plus 200 comes around the same time. Another record gets inserted in the journal table with the same primary key with the operation as plus and the reserved amount of 200. Now it may happen that the second transaction gets committed first. So as soon as the second transaction gets committed, it gets flushed off, the balance gets updated to 700. A little later, the first one gets committed of minus 100, gets flushed off, the balance becomes 600. Now let's assume that another transaction comes, transaction 3 of 600. Immediately, a record gets inserted, 1001, balance as, let's assume that this is a minus 1 and the amount comes to 610, becomes minus and minus 610. Sorry, this is 610. Now, the moment the third transaction gets committed, it gets knocked off from the reservation general table. But if you have a check constraint that this column should not go less than 0, the update will fail. So if an update fails, an error message comes that the check constraint is violated. The journal table gets knocked off, but the balance remains as 600. The transaction 3 fails. So this is how my reservation journal table helps in concurrency. Other points which we should note are, number one, an user table cannot have more than 10 reservable columns. The non-check constraints involving reservable columns are not allowed, which means you can only have a check constraint on the balance field in this example. External temporary IoT tables cannot have reservable columns. You cannot mix reservable and non-reservable columns in this updates in the same statement. And finally, DML and DDL operations are not permitted on the reservable journal table because that's an internal Oracle table. Gives you a very good idea about how lock-free reservation works, a wonderful feature to increase the throughput for concurrent transactions. Thank you.